Alright, so today we're looking at secants. So we talked about tangents before, so now we're going to look at secants and tangents. And so when I'm talking about a secant, so we learned that a tangent line is just like touches the outside of the circle. So that would be that point of tangency, and that'd be a tangent line. A secant line goes into, so chord is actually a secant line because, or part of the chord. The chord is part of a secant line. So a secant line will go through it. So we're going to look at what happens when I have secants and tangents, two secants, if I form angles inside, outside. So kind of a few things, but they all are kind of generally the same. So first of all, if I have two secants and they form, the angle that they form when they intersect is equal to the two arcs that they make, that intercepted arc. So for angle 2, its intercepted arcs are BC and AD. So angle 2 equals the sum of those two arcs divided in half. And then angle 1 is its two arcs. Its two arcs are AB and DC. So it equals the sum of those two arcs and divided in half. So X here, notice X is two arcs that are made with this intersection of this angle, is FG and EH, and I have those two. So X equals 1/2 76 plus 88. So 1/2 164, and then half of that would be 82 degrees. So we're going to see two types of problems with this, where the secants cross inside, or like I said, that if I extended these out, they would be secants, and right now they're chords. So it's kind of the same thing. Or we're going to either see where we're looking for the angle that is opposite or the arcs are involved with, or we're looking for like this angle. So that's going to be the next example. So watch that when you're doing that worksheet. So here I have this arc here and this arc here will help me find these two angles because those are equal. So I'm going to first find those two angles, and then remember that the angle that I'm going to find there with this X will equal 180 because they're linear. So I'm going to do, let's call that angle A. So angle A would equal 1/2 62 plus 96. So angle A equals 1/2 of 158. A then equals 79. So X will equal 180 minus 79 because it is linear with that angle A that we made. So X equals 101. So when the angle's inside, we're going to add and take half of it. It's kind of the mean between the two. If the angle's on it, kind of like an inscribed angle, so here we see a secant and a tangent line, that angle that's formed between the secant and the tangent line is half of the angle that we got, which is kind of the same thing that we saw when we were looking at inscribed angles. So this angle is technically inscribed in there because it's on that edge, not fully in it, so that's why we don't call it inscribed. So QPS, well, its arc is this 250, so angle QPS equals 1/2 of 250. So angle QPS equals 125. Now here I'm looking for the arc BCD. So I have this angle that I got when I took half of DAB. So I took half of DAB and I got 108. So if I double 108, that would give me this arc DAB. So that would give me 216. And then remember, all the way around is 360. So the measure of arc BCD is 360 minus the 216. So watch those. If you're looking for an arc, it's going to be double. If you're looking for an angle, you're looking for half. So I get 144. There is another way I could have looked at it. I know that if I extended out this tangent line, these two angles are supplementary. So this would be 72, and this would be 72 times 2. So either way gives you 144. All right. So I'm going to let you pause the video, work those ones out in your notes, and then we're going to go to now when I have an angle outside. So far we've only had angles on the edge or inside. Now we're looking at either two secants that make an angle outside, or a secant and a tangent that form an angle outside, or the two tangents. So this one is outside, so we do a little bit different. Instead of adding the two arcs that it intercepts, we subtract, and we always do the bigger one minus the smaller. So it's always the furthest one minus the smaller one. So BC here is what we're looking for. Let's call that X. So I know to find 62, so that angle 62 equals 1/2 the bigger arc, the furthest away, 141, minus the smaller arc, which was BC. So I'm going to get rid of this fraction by multiplying both sides by 2. So I get 124 equals 141 minus X. Subtract 141. Right? And I get negative 17 equals negative X. And then I can divide both sides by negative 1. So X equals 17. Here, same thing, but we have a little bit different. We are looking for arc X, Y, Z. So we're looking for this arc. Again, I'm going to put an X there because it's just a little bit easier than rewriting X, Y, Z every time. So I'm going to make that X. So again, I have 40 we got when we took 1/2 of the bigger arc, which is X, minus the smaller arc of 140. So I'm going to multiply by 2 to get rid of that half. So I get 80 equals X minus 140, and then add 140 to both sides. So I get 220 equals X. And if you check that, 140 minus 220, and half of that should give you 40. And then I'll let you work that one out. You can pause the video and check it, but you should get 230. Right, so just to generalize, if your vertex is on the angle, we're going to take half of the arc. If it's inside the circle, we're going to add the two arcs that are formed with it, opposite of it you could think of, and half of that. And if it's outside the circle, we're going to subtract them.